Hello, this is Charlene. We are going to work a quadratic regression problem. Our word problem says a college basketball team had a photographer take time-lapse photos of a free throw to get measurements for the distance from the free throw line and the height of the basketball during the free throw. The following measurements were recorded from the photos. Okay, so we're going to take this chart of data. This first line, the distance, can also be thought of as the x values. This second row of data is the height, and it can be thought of as the y values. We are going to use our graphing calculator to produce this quadratic equation that question A is asking for. Question A says, find the quadratic equation for the relationship of the horizontal distance and the height of the ball. Okay, so we're going to go ahead and pull up our graphing calculator. We're going to turn it on, and we're going to clear it out just because that makes me happy. And then we're going to go to the Stat button. And the first option here, I just clicked the Stat button. The first option says Edit. The Edit is going to take us to columns, L1 columns, L2 columns, etc., etc. We only need 2 columns because we only have 2 rows of data. So if you want to clear all this stuff out, you go up arrow to the L2 and push clear, enter. That clears out the whole column. Right arrow, up arrow to the L1, push clear, enter. So how we're going to put this data in is we're going to just start entering the data. The first row will be the x's, so it'll start with 0, 2, and 6. So we're going to do 0, enter, 2, enter, 6, enter, 9, enter, 12, enter, 13, enter, and 15, enter. Okay, so that's my first row of data. In the L1 column, that's the x values. So I'm going to right arrow over to the L2, and now I'm going to put in my second row of data. It starts with 4, 8.4. So I'm going to do 4, enter, 8.4, enter. Pull that up a little bit. Okay. And then I'll have 12.1, 12.1, enter, 14.2, enter, 13.2, enter, 10.5, enter, and 9.8. And let's kind of look over that, make sure they look good. Yeah, I've got the same number of data points. So now we just push enter. Then we can go second quick, get completely out of there. Now let's go back to the Stat button, but instead of editing list of data, I now want to right arrow over to the calculate option. So I'm going to right arrow, says calculate, and it is in the problem it told us it was a quadratic. So we're going to go down to number 5, quadratic regression. So what it means is that we have real life data points. We do not have an equation. So we're going to take our data points and work backwards to find the equation. That's what regression means, to kind of go backwards. Okay, so at this point it says the X list is in L1 column, the Y list is in the L2 column, and we want to calculate. So we're just going to push enter, 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 enter until it actually calculates. And it produces this screen here. It does have it in the format of ax squared plus bx plus c. It tells us the values for the a and the b and the c. We can ignore this r squared term for this problem. Okay, so I've went ahead and got a copy of what my screens look like on my calculator here. So there's where I put the data in, and here's what it produced. And so it gives us the quadratic of y is equal to the a of negative 0.118. That's what I'm going to put. It says here round to 3 decimal places. So I'm going to say negative 0.118 x squared. And then my b is going to be 2.112. So that's plus 2.112. These numbers are coming from what my graphing calculator told me were the values for the A and the B and the C. So negative 0.118x squared plus 2.112x, and the C is going to be plus 4.215. So that is actually the answer to the first question. We wanted to find the equation, and that is the quadratic equation which best represents this list of data. Okay, so we've got a second question here. My second question says, using this function, what is the approximate maximum height of a ball? So if you remember that you're talking about a ball, you're talking about if we have an x and a y coordinate, there's the y-axis, the x-axis, and we're measuring this, and we've got this parabola. It might look something like that. The maximum height is going to be the point that's at the tippy top of that parabola. Well, that point at the top of our parabola is also known as the vertex. So in order to find the maximum height, I need to find the vertex. The vertex will be an x and y value. The x will actually be the time, and the y will be the height. So the y value of our vertex will give us the answer. So how are we going to find the vertex? Well, we are going to use what I refer to as the magic bullet to find the x value of the vertex. So the magic bullet that I refer to is the negative b over 2a. So that little formula right there, little equation, little fraction, is going to give us the x value of the vertex. Okay, so negative b means negative this number, and you can see I've listed it right there. And then 2 times a, so it's 2 times this a number, and I've already plugged those in here. And it does, if you use your calculator, you can check me on this, it is approximately 8.949. That is the x value. So that means that vertex over here has like 8.9, approximately. 8.9 is the x value, but the x value is going to be about the time, the number of seconds that the ball is traveling. Okay, but we want to find the height. So what we're going to do, we are going to take this number right here, that is the x value of the vertex, and we're going to plug it back into our quadratic. So let's kind of take that again. We're going to take our x value, plug it back into our original equation that we found using our graphing calculator. So when we do that, we are going to have y is equal to negative 118, and then the x will be our x value, so that will be the 8.949, and that will be squared, and then it's going to be plus the 2.11, so plus 2.112 times the x, so the x is going to go right there again, 8.949, and then it's plus the 4.215, so 4.215. So we are going to take this entire equation, and we are going to just take our graphing calculator and we're going to crunch it out. Okay, let's turn it back on, go second quit to get to a clean screen, and let's see if we can get that number in there correctly. Let's see, just make sure that I have a point. That's negative 0.118, so don't forget your decimals. Pull the calculator back up again. Okay, so we got negative 0.118, and then 8 times 8.949, and that number is squared, and then it's going to be plus 2.112 times the x value, 949. Did I get it all in there right? Yep. And then plus my C number, which is 4.215. Okay, so let's kind of look over that and make sure we've got everything in there correctly. I can back arrow over that, and it looks like everything is good. So I'm going to push enter, and it looks like that the height of the ball, the maximum height, the max height, is going to be equal to 13, and what did it say there? 13 point, let's round it to just 13.7. 13.7 feet is how high that my ball is going to go on its way to the free throw net. That is the answer. That's also the Y value of my vertex, so like 13.7. So hopefully that helps you understand how to think about these problems. This is how we generate the equation using our calculator, and this is how we find the vertex and therefore the height, the maximum height that our basketball is going to before it hits the basket. Okay, you just have a great day. Come back and see us soon. Click on the like button, click on the subscribe button,